Hello, everyone, and welcome to all our participants worldwide. I am David Jordan, Senior Global Sales Manager at your group, and I will guide you during this webcast. Today, your group is pleased to organize a webcast on semiconductor trends in automotive. This is our last webcast for the year. To tackle this topic, let me introduce our speaker, Eric Mouillet, Director of Research, Fellow at Short Development. Slide 3, before we get started, we remind you that you can use the Q&A box to submit questions to our analysts during all the live event. You have the box at the bottom of the screen. All the questions will be answered at the end of the webcast. And in case we don't have time to answer all of them, we will follow up via email with you. To conclude, this webcast will be recorded and the presentation, as well as the replay video, will be available next Thursday on our website, yourgroup.com. So now let's start the webcast and welcome Eric. The floor is yours.
Okay, thank you, David. So I will first start by sharing my screen. And I think that's it.
It's coming, yeah.
Okay.
It's okay.
Okay, so thank you, David, for the introduction. So I'm pleased today to talk about the automotive semiconductor trends because, as you probably know, there's a big change, both in the industrial supply chain for automotive, but also in the technology. And this is what we will discuss today. So just a very quick snapshot about your development. So we are a strategy and consulting marketing company covering all semiconductor industry, covering semiconductors, memory, computing, but also photovoltaic lighting, sensor imaging, RF devices, compound semiconductor, electronic system, and emerging technology such as quantum technologies. Then we have different products, report, monitor, track, and custom survey. So I will not go through this slide, but just as an indication, we release more than 100 reports by year. Actually, we are a global company. That means we are a group of companies, Yole Intelligence, doing market technology and strategy consulting. Your System Plus, sister company doing technological analysis, tear down, and cost and comparative analysis of component and system. And PZO doing characterization of electro-optical performance and risk, and specification design and visualization of system, especially photonic and optoelectronic system. We have a global presence worldwide, almost 200 collaborators in 9 different countries today. So the headquarters is in Lyon, where most of the analysts are, but we also have people in North America and in Asia. So this is the start of the presentation because actually, as I said, we cover all the semiconductor industry. We also call chips or microelectronics for 6 different markets. Our portfolio of customers range from academic research up to investors. And today we will cover automotive industry. So the content of my presentation will be the following. I will first talk about automotive semiconductor market forecast. Then I will talk about the career of semiconductor growth for tomorrow's car. Because there is big changes in semiconductor industry today, I will, of course, mention what's going on about supply chain, and then I will conclude. Let's start with some market forecast for the automotive semiconductor industry. So first, as a general introduction, there's currently a lot of different forces that will have a durable effect on the automotive industry. Long-term impact will imply electrification that will also in turn imply a lot of increasing semiconductor content. We can also include in that the autonomous trend for car, we will move from level 2 to 3 to 4 to 5. That will require increased semiconductor, more computing, increased performance of sensor, more memory, and so on. Of course, we also just get out from a COVID era that lead to a lot of disruption into the supply chain. What is also new is that newcomers are entering the automotive car game, with company like Tesla, but also big semiconductor companies like Intel that bring their own semiconductor to the automotive industry. And we will see that these things will also have a strong effect on the supply chain of the car. We have the China-US trade war. So there's a strong also effect on the automotive industry as China is trying to become self-sufficient, but also trying to externalize its car industry, selling car outside China. And we can also short-term impact this international conflict, which Ukraine and Russia war, and also chip shortage, which has raised the price of the car today. And also it's becoming much more difficult to have access to the chips. And we will see that depending on the kind of chips, the technological node, that's different issue related to the chip shortage. So actually, what is interesting is that inside the car, you have a wide range of different semiconductors. We got analog, ASIC, image sensor, memory, MEMS, MCU, what we call other sensors, specifically environmental sensor, but also magnetic sensor. We got a lot of photonic devices like LED, laser diode, VCSEL, photodiode. Many components are dedicated for the power management. It can be power discrete or power module. We got processor like FPGA, and it will grow in the future due to increasing need for processing power for autonomy. And we got RF devices for connectivity in the car. So almost every chip in semiconductor can find a place into a car today. So let's start with the market value. So in 2021, we have estimated that the semiconductor market for automotive was 44 billion of US. If we see the split, we can see that most of the value is for power devices, but we have also big number for imaging, photonics, MCU, processor, and also RF or MEMS devices. In 2027, we estimate that the semiconductor market for automotive will be above 80 billion of US. So there will be, of course, a big growth for power devices, both for discrete and module. It will be driven by new material like silicon carbide, gallium nitride, but also IGBT. Specifically, it will include both discrete and power module, for example, for fast charging applications. RF will be used for V2X, but also for radar. And the radar will also be very interesting technology for ADAS and autonomous vehicle. MCU will have increasing value because we will require more MCU for ADAS and also for the management of sensor. Photonics is also an important market, important technology for lighting, both for interior lighting and exterior lighting. Imaging, also, just to finish with that, we have quite a significant growth because it's very critical technology for increasing level of autonomy, but also for ADAS. And the number of CMOS image sensor will increase in a car in 2027. Almost every car in the world will have at least one camera, but we are heading toward a roadmap of at least 12 camera inside the car for level 3 autonomy and above. Of course, even for imaging, we will see new technologies like SWIR or event-based imaging technologies. if we compare what is the semiconductor share for automotive application, it's quite significant. In 2022, we have estimated that the automotive sector value is close to 8%, and in 2027, the semiconductor value share will be close to 12%. So it means that by 2027, the semiconductor industry will have quite a sweet spot in the automotive applications. Now, let's go into details. If we look at shipment volume, in 2022, we count that every car, or let's say 2021, sorry, every car has about more than 100 chips in a car. In 2027, the number of chips by car will be 1,100. And in terms of value, it means that for the 120 chips by car, this is a total semiconductor value of $500. In 2027, we estimate that the 1,100 chips into a car will represent a semiconductor value of almost $1,000. To be more precise, it's between $900 and $150. This will be driven by two main trends, and I will often refer to this trend during my presentation, which are electrification and ADAS, that will be the major trend for the growth of semiconductor content in automotive. In terms of wafer shipment, so actually, there will be quite a significant growth for 12-inch wafer, because I would say that processors such as GPU, FPGA, MCU have quite a large die size. That means that they will require quite a large number of wafers to be processed for this kind of device. At the end, we have estimated that the wafer shipment volume for all wafer size will go from around 21 million units in 2021 to around more than 30 million units in 2027. So if we look at the breakdown for the total wafer shipment for the car by node, we can see that discrete and module devices that are mostly above 350 nanometer represent the largest share of the wafer shipment volume. Also, for node above 350 nanometer, we also include MEMS and sensor. It's interesting to see that for the small node below 28 nanometer, they will have the highest growth rate, and it will be driven by ADAS, and especially MCU for auto application, which are driven by cutting-edge technology with node as low as 16 nanometer and 10 nanometer expected by end 2022, will also participate to the growth of the lower node wafer shipment. We have estimated that by 2027, this will represent about 5% of the automotive MCU that will be used for ADAS and radar. Also, for memory, specifically DRAM, they are all based on the 28 nanometer node and smaller, and it's also be the case for 95% of the NAND memory, the rest being on 28 to 65 nanometer nodes. It means that there will be quite interesting opportunity for smaller node technology in the car, and it will be driven by MCU and memory. If we look now the breakdown by type of wafer size, so it's not a surprise that 8-inch wafer will be the largest contribution to the total market. For 12-inch wafer size, 12-inch wafer shipment, they will be mostly for memory, processor, and MCU. And total number of wafers to be shipped in 2021, it will be a bit more than 21 million wafers, all wafer size included. And in 2027, the total number of wafers to be shipped for the automotive industry will be a bit more than 31 million of units, all wafer size included in that. But what is also interesting that driven mostly by electrification, new materials will be processed using semiconductor manufacturing technology. So for example, silicon carbide will grow quite fast due to electrification, due to xEV market. It will be used for onboard charger, DC-DC converter, and main inverter. But we see that the main inverter will be the most significant opportunity for silicon carbide technology penetration because of the high power range that will be needed for that. It will be also very interesting technology for the shift to hybrid voltage system that could represent almost 25% of the total BEV vehicle in 2030. And we already see a lot of Chinese players, Chinese OEM, that's currently scaling up silicon carbide production for ultra high power density, ultra high power DC charging. Of course, most of the manufacturing will be on silicon, as you can see on the chart, but there's really a strong push actually for silicon carbide, but also gallium nitride technology, and also gallium arsenide and sapphires. The latest being more dedicated for photonics and lighting application, which also present nice market opportunity for the automotive industry, both for interior lighting and exterior lighting. Here, the graph shows the average content percentage in terms of revenue on volume of semiconductor chips in a car for 2021. So I said previously, in 2021, the semiconductor value in a car was more than $500. Most of the value is for power devices. Then we got MCU because they are quite expensive chips. And this $510 is a total of 900 chips, mostly power devices for battery management, power engine management, and so on. Now, let's have a look at the key area of semiconductor growth. There is this well-known acronym CASE, which can summarize what are the trends in the automotive, what are the mega trends in automotive. The A is for autonomous, with increasing level of autonomy, 1, 2, and now we got one car, which is level 3, which will require a lot of different sensors and, of course, increasing computing development for safer road. We ought to see for connectivity or cockpit to improve the comfort and entertainment for the passenger, and also more security and safety for the driver. The S is for share, for new business model into sharing the car. And the E, of course, is for electrification. It's, of course, the alternative technology drive system to reduce CO2 emission, which is also the main trend today for economy saving and for the clean energy shift of the planet. Actually, there are not the same market momentum for these four trends. Sharing is, as you can see, it's quite slow into the adoption of this new trend. Actually, the Uber-like sharing business has been quite flat. Still, most of the people want to have their own car. And if we consider robotaxi as part of the sharing model, it will only come with level 5 technology and it's still far away from today. Electrification on the other hand, has a very strong momentum and will continue for the next year. Connectivity is steady rise as there is 5G adoption, and also there is interesting development toward what we call smart cockpit technology. Actually, we can see driver monitoring system as one way of smart cockpit technology, and there's greater regulation in Europe and in North America to have driver monitoring system into new car. Autonomous driving, this will continue. ADAS will increase rapidly. There will be many more sensors in car, image sensor, maybe 3D technology, night vision system, radar, maybe LiDAR, but L4, L5 is still far away from mass productions. Anyway, if we consider only two trends, autonomous and electrification, we can see that most of the chart pie I showed previous, in this chart, there are already most of the components that will be dedicated to either autonomous vehicle or electrification. So it will be imaging, photonics, power, memory, processor, MCU, and ASIC. And for all this technology, they will represent almost $70 billion out of the 81 billion for all the technology, all the semiconductor technology in a car in 2027. Now, let's have a look at the different evolution of the module. Specifically, because of electrification, we need big technical evolution into the module. So for electrification into a car, there's 4 modules. One is a DC-DC converter to convert high voltage to low DC voltage, to power light or fan and so on. We got the main inverter, which must control the electrical motor. We got the onboard charger to convert AC to DC. And we got the battery management system, which ensures reliability and safe operation of the electric vehicle batteries. And one big trend in the power trend is to move to AndroidVolt system. And this is where silicon carbide will come in play. Why that? The benefit of silicon carbide for Android voltage is first, silicon carbide MOSFET has a better high voltage than silicon MOSFET. We got better high frequency than silicon IGBT. And also already for 400 volt, silicon carbide already has higher efficiency than silicon, and this will be even better with AndroidVolt. So there are already a system, I mean car, vehicle on the road that is using silicon carbide MOSFET for Android voltage. Now, if we look at a summary of the different technology trends for power electronics, so we discussed about the first one, that is moving from silicon to silicon carbide. Then the second one is moving to increase voltage level to AndroidVolt for ultra fast charging, to have a better energy conversion efficiency, more compactness, and relaxed cooling. The third one about packaging, to move from single-side water cooling to double-side water cooling, because as you probably know, there are 2 challenges for the packaging of power electronics. One is specific consideration for high voltage, high power, high frequency, and heat dissipation. And the second is related to high standard lifetime reliability to the automotive standard. And the last one is system integration, moving from standalone MCU, DC-DC, onboard charger into single housing to a full integration that will happen at different levels. It can be done at the mechanical housing or at the power board level. All these trends are driven, of course, by efficiency, cost, and performance, of course. Other type of module in a car are related to safety. So we got many different safety modules in a car. We got imaging module, camera module for forward ADAS, radar module for long range, a camera module using micromonitor for night vision, LiDAR module for 3D sensing, front lighting, TPMS camera module for surround view, or even rear view module. And a third type of module is for the user experience inside the car. It can be for the driver or for the passenger. So some modules are dedicated to increase safety, in the case of drowsiness monitoring module. Some are more related to entertainment, more for the passenger, like infotainment module, telematic module, or for the comfort of the driver and passenger, like air quality module with particle sensor or gas sensor or environmental sensors. So all that means that there are already a lot of sensing module into a car. And there's one car on the road which is already level 3. That's the only one. That's the Mercedes-Benz car. That's open sale level 3 self-driving car on the SClass. They will call it the SQS. They start the commercialization in May this year. And you can see that there are different camera modules for a lot of purposes. There's LiDAR, front long-range radar, multi-purpose camera, rear multi-purpose camera, driver camera, moisture sensor. This is more related to environmental sensor for the quality of the air cabin, and also some redundant electrical, brake, and steering system. So, and also interesting to see that additional microphones have been also added to detect emergency vehicles. So this level 3 is an option that today will cost you more than $5,000 if you want to have it integrated into your car. So it means that there is still a long way to move from level 1 to level 2 to level 3. And we have defined intermediate level between level 2 and level 3, because actually, if we look at what will be the required functionality to move from one level to another, moving from level 2 to level 3 will require a lot of computational power. As a rule of thumb, you have to think that when you go higher to every level, you will multiply the level of required computing performance by 10. It means that for level 1, you have 0.25 TOPS, level 2 plus 2.5, level 2 plus 25, level 3, 100 TOPS, and level 4 and above, 500, maybe to 1,000 TOPS. It means that it's not possible moving from level 2, which is less than 1 TOPS, to level 3, which is more than 100 TOPS, sorry. So we need to define level 2 plus, level 2 plus with intermediate additional function that will allow increasing computing power that will go step by step. If we look at the specific case of the camera, so actually it's interesting to see that camera module based on visible image sensor is a very critical element for ADAS and also for autonomy in car. We will move from 2 cameras on average for level 1 and 2 to 5 for 2+ level, to 11 camera for 2++, up to 20 camera for level 3 car. As a reference point, the market average is 1 to 5 camera into a car. And in 2027, whatever the level of autonomy or ADAS of the car, every new car will have at least one CMOS image sensors. It's interesting to see that this industry, I mean, this opportunity to integrate more image sensor camera into a car are good opportunity for semiconductor players like Intel, Qualcomm, or Samsung that are gaining increased market share into the automotive market. The point of view also is so different depending on the type of player. For example, Tesla is strongly believe into CMOS image sensor for autonomous car. They do not believe into radar or LiDAR. And also the case for Intel that still strongly believe into 4D radar for increasing level of autonomy. Visible imager will not be the only technology, and we can see also new technology entering the game, like a SWIR technology or uncooled microboliter in 2025 for night vision imager into car. So main technology, as I first mentioned, some semiconductor company entering the game. So actually, there's a big reshuffle of the supply chains, which can be described by four things. The first is vertical integration. It means that because more electronics, more semiconductor is integrated into a car, the OEM need to grab more value into the supply chain just because they need that if they want to stay alive and to manufacture very high technological car with high level autonomy, high content of memory, high performance computing, and so on. The second is a segmentation. I mean, the OEM cannot do everything. So they will focus more on new segments such as power electronics and high performance processor, which will be critical both for electrification and safety. The third point is strong difference into the different world region. Actually, Chinese is very aggressive into the automotive business, and the recent policy in China has built a very competitive supply chain landscape internally and for electric vehicle, and they currently trying to expand internationally. But the game is still open. I mean, both OEM and Tier 1 still have to define a very clear strategy toward what they will do with semiconductors. Because the specific expertise in semiconductor and supply chain, both internally and externally, is very difficult to acquire. So it's very urgent for them to develop their roadmap to get prepared to the increasing integration of semiconductor for the future generation of the car. But it does start already. In this chart, you can see what have been the strategy of the OEM, what have been the investment for the different semiconductor device. So you can see that for power electronics and software, and also battery related to electrification, there's a strong involvement of OEM. And companies like BYD, for example, are strongly involved in both power electronics, but also ECU, but also auxiliary and battery. And we also see new suppliers coming from semiconductor, trying or offering a semiconductor for the automotive industry. It's okay for Qualcomm or Foxconn, LG, or even Google, Huawei, Alibaba, or Apple that's currently developing software for the automotive industry. And this is specifically true in China. You can see on this table what are the Chinese OEM investment in semiconductors. And here again, there is investment at each level of the semiconductor devices. And also interesting to see that on the right part, you got Xiaomi and Huawei. And interesting to see that the strategy of this company are quite interesting. Xiaomi aims to become electric vehicle OEM, and Huawei have chosen to be a supplier to supply key system in close collaboration with selected OEM for the car industry. So it means that if we look back to the historical supply chain of the automotive, which is the top level of the chart, we have very well-defined OEM doing vehicle manufacturing, then we come T1 doing system, then we got chip design, and at the very end, we got foundry and OSAT with very clear role, kind of a silo between each business model. We see emerging business model where it's well-defined, it's well less defined, and some company like GM, we will both and doing vehicle and system. And some companies, for example, like Tesla, will go from the vehicle up to the chip design. We got also some company like Foxconn or Huawei, we will not maybe go up to the vehicle manufacturing, but they will expand their know-how to do both chip design and system manufacturing. And the last thing is that some company will be fully integrated. The case, for example, BYD, that will be do vehicle, system, chip design up to the foundry level. So it's a big disruption. Actually, it's a big change compared to the historical supply chain of the automotive. It happened quite fast. Actually, it happened over the 5 past years. So just a last word about what kind of technological node will be required in the automotive industry and what will be the impact of the supply chain and on the chip shortage. So, of course, for more computing power, for MCU processor, we will need technological node below 28 nanometers. But actually, the trouble in terms of chip shortage is more for the nodes which are above 28 nanometers. That the main nodes that are impacted by the chip shortage, because the nodes are also used in other functions, in phone, and audio, IoT, blah, 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 and there's currently a bottleneck into the chip production for all these nodes. Because, yes, these components are used also in multiple applications, not only in automotive. So let's move to the conclusion, and I will summarize in 3 points. The first one is that, of course, semiconductor will become more and more important in car, and also it's very interesting to see newcomers coming from the semiconductor field joining the race. And it's good opportunity for the semiconductor market because the market will almost double in 6 years. The second point is that vertical integration is becoming very popular, and it can be accomplished in different ways, in multiple ways. Actually, it can be full integration done to component level, system integration with a subcontracting build-to-print part, and also strategic cooperation or direct investment with key component supplier or foundry or semiconductor chip maker. And this is specifically true for electrification. And the last point is that the recent, I would say, geopolitical event, chip shortage, but to China-US trade war, at a lesser extent, the Ukraine-Russia war is also developing manufacturing localizations. So thank you for your attention. This is my email, and also on the right side, you have all my colleagues also who have been working with me on the report. So we can also contact them, Pierrick or you, if you have any question related to semiconductor market for automotive. Thank you.
Thank you very much, Eric. We have received many questions during the webcast and propose to answer 3 of them. Let's start with the first question. Can you elaborate on the increasing demand for computing power for autonomy level 2 and above, and also what will be the consequence for the OEM strategies?
Okay, so this is interesting because actually it's also what I start to mention to my presentation. Actually, 30 years ago, the OEM did not have even any need for computing, or it was a minimal need. But computing power is becoming more and more important for level 3, level 2, 2+, 2++, level 3, and so on. So since 2020, actually, OEM has started developing their own software solution. And because, as I said, at every level of autonomy, the computing power is multiplied by 10, this trend will continue. So for example, Volkswagen has created a specific software division in 2020 to deal with the software issue in the car industry. And we believe that other OEM like Mercedes or General Motors will follow the same trends. And probably we will see other OEM in the future having the same way of thinking, developing their own software competencies. It's quite difficult to invest into semiconductor hardware, but at least they can invest into software for computing.
Okay, nice. Second question. With the new player from the semiconductor industry, what will be the impact on development time and lifetime of cars in the future?
Yeah, actually, I hope that with the presentation, you see that the car is becoming some sort of consumer goods, like a smartphone on wheels. So up to now, the car industry had a very well-defined roadmap. Quite long time for the development, was at least 4 to 7 years of development. Then we got another 5 to 10 years of serial production, and we got 20 to 30 years for the spare part availability. So this is for the car industry. So it's tens of years. For the smartphone and consumer industry, it's totally different. So time of development of the smartphone is 10 months, and the lifetime is 2 to 3 years. So we believe that because of the increasing content of semiconductor, and there will be less mechanical part, more need for software upgrade, I would not say the whole, but the former roadmap with the long-term approach of the industry maybe will be shortened. So maybe we will see shorter development time, 4 to 7 years, maybe to 3 years development, maybe 5 years of serial development. I believe the spare part availability, they will be probably the same, because a car is not a smartphone. It's related to your own safety and security. So you need to be sure that we have still have the right component in case you want to replace them. But yeah, we believe that actually all this change will have also impact into the, I would say, traditional car industry roadmap development.
Right, clear. We have time for our last question. So it's about car electrification transition. this will not be beneficial to all technologies. And so the question is, which components may appear or disappear in electric vehicles compared to traditional vehicles?
Okay. Yes, because again, this is interesting. We're moving from mechanic system to an electrical system, so there will be a less component at the end, which means that some industry will suffer. That actually, we estimate that when we will move from thermal vehicle to electrical vehicle, about 100 component, traditional, I would say, component, will be eliminated. On the other hand, BEV will require 31 new components. So some will disappear, some will appear. And if we look at a specific example of MEMS, so that's an interesting case because I've been involved in MEMS for a very long time. And for example, pressure sensor have been used for numerous application in engine management, for the pressure, for the fuel level. And yes, this kind of MEMS will disappear. On the other hand, I believe the tire will be different for electric vehicles. So probably TPMS based on main pressure sensor will continue to exist and related to safety. And I believe the tire will be different for electric vehicle than for thermal vehicles. So again, the pressure inside the tire will need to be very tightly controlled. So there will be some interesting need for increased performing TPMS, and also for sensor, because we will have electrical engine, we will make probably more magnetic sensor, but also thermal sensor to control the heat of the electrical engine. So some disappear, some technology will probably disappear, some will appear. So will be some kind of trade-off.
Yeah. Okay. Thanks. Thank you very much, Eric, for your time and for all your answers. The webcast is now ending. Let me remind you that you can find all our products on our website, yolgroup.com. Feel free to subscribe to our communication and stay informed about our latest news and product launch. I'm also glad to remember you that you will receive the replay video and the presentation next Thursday. It will be available on our website. If you still have any questions, you can ask us through the different emails that we've shown you, and we will also come back to you for the remaining questions that we did not answer right now. Finally, we'll be glad to meet you again online next year with a brand new webcast offer, so stay tuned. Now, the webcast is ending. Thank you very much for joining us today, and we wish you all a Merry Christmas and a Happy New Year season. Thank you very much. Bye-bye.